learn how to find the area of composite figures. There are different strategies to finding the area of composite figures, which is a figure that is made up of multiple other shapes that we know how to find the area of. The example on the left, the one that looks like a snow cone, can be found by adding the area of the two shapes that we split that up into, a triangle and a semicircle, to find the total. The example on the right is looking for just the area of the shaded portion of the rectangle without that triangle in the middle, and we can find that by subtracting out the area of the piece we don't want. So let's take a look at some examples of both. When you are trying to find the area of an odd shape, we have to split it up into shapes that we do know how to find the area of. These can be split in a few different ways at sometimes. Sometimes it is easier one way than another, but it depends on your what information you're given and the figure to know which is the easiest way. So first thing we want to do here is decide, how am I going to split this figure up to find the area? We can split it across the top here like that, or straight down to find two rectangles. I'm going to do it this way, but you can actually do this both ways. We'll call this shape A and we'll call this shape B, just so we know with our work what we're working on. So rectangle A, the first thing I like to do is write down the formula for the shape that I am working on, and this is a rectangle, so that's length times width. The length of this rectangle goes from the end to here. It is not 5 feet, because 5 feet is the entire bottom length. So we need to first figure out what is this length of this rectangle A. If the total is 5, we need to look all the way up here to see that just from here to here is 2, meaning if this portion is 2 and the total is 5, this piece over here would be 3. 3 plus 2 is the total, which is 5. This here is a width of 3. This is actually a square, and we can replace this with the square formula. We didn't know necessarily at the beginning that it was a square. It kind of looks like one, but we don't want to assume until we figure it out. So we could do either one. A square is a rectangle, so you can do area equals 3 times 3, or you could say area equals 3 squared. It's the same thing. 3 times 3 is 3 squared, which is 9 square feet for rectangle A. Rectangle B, same formula. This one's definitely a rectangle, not a square. We already know the length of this one is 2 and the width of this one is 4. Nothing to figure out there. Just multiply to get 8 feet squared, and then our total is found by adding the two together for a total area of 17 feet squared. Now let's take a look at the example I mentioned at the beginning. Again, we have a triangle here on the bottom, and the top is a semicircle, which is half of a circle. First, let's start with a triangle. We'll call that shape A, and we'll call the semicircle shape B. Our triangle formula is 1/2 base times height. The base of this triangle is 6, and the height is 10. So I'm going to replace B with 6 and H with 10, and then evaluate what that value is. Half of 6 is 3. 3 times 10 is 30 centimeters squared for the triangle. Then we're going to do the semicircle, which is shape B. Our circle formula is pi times the radius squared, but this is a semicircle, which is half. So we're going to need to divide that answer by 2, because the formula for a circle will give us a full, complete circle, and we only want half of that. The radius of this circle is halfway across. So if the total distance, the diameter, is 6, our radius is 3 squared, and then we will divide that all by 2. If I use 3.14 for pi times 3 squared, that gives us 28.26. Divide that in half, I get 14 44.13 centimeters squared for my semicircle. The total will be found by adding those two things together for a final area of 44.13 centimeters squared. What is the length of the base of the triangle portion of this figure? Take a moment to figure that out. We would need to look all the way down here at the length of the rectangle being 8, and then also compare that to what we know up here at the top of the rectangle. If the total is 8, take away this 2, that makes 6, take away one more, that makes 5, that length would be 5 centimeters. We would need that if I wanted to find the area of that triangle up top, because we need the base of the triangle and the height. So that would allow us to find the area of that triangle and then find the area of the rectangle and ultimately add them together to get a total of 52.5 centimeters squared. Now let's take a look at the example I mentioned at the beginning, where we would need to subtract the area of a shape away from a total area. So we are going to take the area of the full shape here as a rectangle. That is, we'll call that outside shape A, and we'll call the inside portion shape B still, just so we know what we're working with here. You can also identify them by the name of the shape if that is easier for you, so you know what you're working on. But the rectangle, again, I like to always start by writing down my formula so I have it right in front of me. The rectangle has a length of 12 and a width of 10 for a total area of 120 inches squared. Now I need to find the area of that triangle inside, which is 1/2 times base times height. The base of the triangle, if it's sideways, is 6 and the height is 4. So 1/2 of 6 is 3 and 3 times 4 is 12 inches squared. Now we want to take that triangle and cut it out of the full area. This rectangle, 120 inches squared, that will cover the entire rectangle that includes the triangle, but we don't want that triangle. So in order to cut it out, we're going to subtract 120 minus 12 for a total area of 108 inches squared. Okay, I think this is our last example. This one is a little bit tricky. We're going to start with the rectangle. We're going to find the full area of the biggest shape. That's the rectangle. And then we're going to find the area of the circles and get rid of them and take them away from the rectangle. So we're only left with those slivers around the outside of the circles. So the easy part we'll start with is the rectangle. Length is 21, width is 10.5. That is a total area of 220.5 centimeters squared. Now, our circles are identical. So we are going to take our area, which is pi times the radius squared, and instead of cutting it in half like we did with a semicircle, we're just going to double it for both. Okay, so our radius here, let's figure this out. Radius is halfway across one of the circles. Oops. Let me erase these x's so I can draw in my circle. So we know about the circle that the distance all the way across the whole rectangle, which goes across both circles, is 21 centimeters. Half of that would go across one circle, which is 10.5. It happens to be the same as this way if you look at it this way. That's the same thing. The distance straight across the circle, the diameter, is going to be the same whether you go, any direction, as long as you're going straight through the middle. So we have a diameter of 10.5, but again, we want a radius. So we still have to cut that in half again. So half of 10.5 is 5.25. So our radius is 5.25 squared. And then again, we're going to double it because we're working with two circles. So if you do pi times 5.25 squared, you end up with 86.54625. Double that, you get 173.0925 centimeters squared for both of our circles. Now we want to know what is the area of this rectangle with the circles cut out. So we're going to subtract those together for a final answer of 47.4075 centimeters squared. As an added practice, find the length of UA if it is 1/4 of RA. And then you can find the area of the shaded region after that. 1/4 of 24 is 24 divided by 4, which is 6. If I wanted to find the area of the shaded region, I can recognize that it is a trapezoid, or I could do the rectangle and then find the area of the triangle and subtract it out. So I actually have two options here. Sometimes our shaded region is a shape that we can simply find the area of. If I do the rectangle, I would do 32 times 24, which is 768. And then if I find the area of this triangle, I now know that my base is 24 and my height is 6, and that would give me 72. And then if I subtract those two, 768 minus 72, I would get a total area of 696 for this shaded region.